This lesson is on ionic compound formation. So first we will have a review of ion formation. Then we will look at the electron transfer using electron dot structures. Then we'll learn how to write the formula of the compound and the name of the compound. You will need a periodic table for this, so you can pause the video and retrieve your periodic table. Okay, so review. So metals, when they become ions, they lose their valence electrons to have the same electron configuration as the noble gas before them on the periodic table. So let's write that down. So metals lose their valence electrons to have the same electron configuration as the noble gas before them on the periodic table. All right, so it's important to remember that metals lose their valence electrons to have the same electron configuration as the noble gas before them on the periodic table. And metals make positive ions, which are cation ions. All right, so now what we say about metals, we're going to say the opposite about nonmetals. So nonmetals, they gain electrons into their valence shell to have the same electron configuration as the noble gas after them on the periodic table. Okay, so nonmetals gain electrons into their valence shell to have the same electron configuration as the noble gas after them on the periodic table. So our nonmetals make negative ions and they are anions. So our cations are positive and our anions are negative. Okay, so let's look at an example of a metal. So we'll look at magnesium. So magnesium. We're going to look at magnesium, and we'll look at the magnesium ion. Okay, so we locate magnesium on the periodic table, and now let's write magnesium's electron configuration. So magnesium is 1s2, 2s2, 2p6, 3s2. So remember that the electrons in the outermost main energy level are the valence electrons. So these 3s2, these are the valence electrons. And the rest of the electrons, these are the core electrons. All right, so magnesium, when it becomes an ion, is going to lose the valence electrons. And, whoops, we'll put that over here. Magnesium, when it becomes an ion, it loses those valence electrons. So we have 1s2, 2s2, 2p6 for the configuration. We don't have the valence electrons anymore. So if we look at magnesium in terms of the Bohr model with our shells, so magnesium has its nucleus, 2 electrons in the first main energy level. We can call that a shell. And then we have 8 electrons in the next main energy level. Call that a shell. And then magnesium has 2 electrons in its third level. These are the valence electrons. The magnesium ion is when magnesium has lost those 2 in the outermost occupied energy level. So the magnesium ion has the 2 electrons in the first energy level, and it's got the 8 electrons in its second energy level. And that's it. It doesn't have a third energy level. For our magnesium atom, we have 12 protons in the nucleus, and we have 12 electrons surrounding the nucleus for a total charge of 0. Plus 12 and minus 12 is equal to 0. For our magnesium ion, we still have 12 protons because we still look at magnesium on the periodic table. It's element 12, 12 protons. But we've lost 2 of the 12, so now we only have 10 electrons left. So plus 12 and minus 10, we have a charge of plus 2 for our magnesium ion. The formula of magnesium, the neutral magnesium, is Mg. The formula for the magnesium ion is Mg2+. Whoops, kind of went off of the screen there. Mg2+. All right, so now let's take a look at a negative. Okay, so we're going to look at fluorine. And the fluoride ion. So notice that ends in IDE. Our negative ions end in IDE. So it's the fluorine atom and the fluoride ion. All right, so let's get our electron configuration for fluorine. And we see that as 1s2, 2s2, 2p5. So fluorine is a nonmetal. It is going to gain electrons into its valence shell to be like the element after it on the periodic table, which is neon. So the fluoride ion has the same configuration as neon, 1s2, 2s2, 2p6. The fluoride ion gains 1 electron into its valence shell. So if we draw that, so we have 2 electrons in the first level, and we have 5 electrons in the second level. 7 electrons. 2 and 5, we have 7. 1, 2, 3, 4, 5, 6, 7. The fluoride ion has those 2 electrons in its first level, and now it has 8 electrons in its second level. So our fluorine atom, we have 9 protons and 9 electrons. That add up to 0. And for our fluoride ion, we have 9 protons. It's still fluorine. We have gained an electron, so now we have 10 electrons. Plus 9 minus 10 equals a -1. The formula here is F minus. The formula here is F. So our nonmetals gain electrons into their valence shell, and when they do that, the atom gets a little bit larger because we have more electrons that are repelling each other. And if we go back and look at our cations are always smaller because they lose an entire main energy level. Here we have 3, here we only have 2, so our cation is smaller. And with the magnesium ion, going back to this, we have 8 electrons in the highest occupied energy level of our ion, so we have the octet. Here we do not have the octet because we have these 2 valence electrons. With fluorine, with our ion, the fluoride ions, we have the octet. That's 8 electrons in the outermost occupied energy level. With fluorine, we do not have the octet because we only have 7 electrons. Octet is 8 for 8 electrons in the outermost energy level. Okay, so now we're going to move on to learning how to figure out compounds using electron transfer. So we're going to start out with magnesium and fluorine. So we're going to make a compound from magnesium and fluorine. So our first step is to do the electron dot structure for each of our elements that are going to make up an ionic compound. So magnesium, Mg, it is in group 2, so we have 2 valence electrons, 1, 2. And then fluorine is in group 17, so it is 7 valence electrons, 1, 2, 3, 4, 5, 6, 7. So now we know that metals want to empty out the electrons in their valence shell, and nonmetals want to complete their valence shell. They want to have 8. So magnesium can transfer this 1 electron to the fluorine, right there, and I'm just going to designate that by a little star. That's an electron. So now magnesium has lost that electron. Oops. And fluorine has gained an electron. Now it has the octet. It's good, but now it has a charge of -1. So this is F minus, that fluorine. Magnesium still needs to get rid of this electron because it wants to empty out both of its valence electrons. So what we're going to do is we're going to add another fluorine. So we write our fluorine and put in its electron dot structure with our 7 electrons. And now this electron can be donated to this fluorine. And this fluorine, after it gains an electron, is now F minus. Magnesium has lost 2 valence electrons. So when you lose electrons, you become positive, and it's a 2+ for 2 electrons. So now we're going to write the formula. And the way we do this is we always put the cations first. So our formula is Mg and then F2. So we put the number of the ions, but we do not put the charges into the formula. We have 1 magnesium ion, so 1 Mg, you don't have to put the 1 here. We have 2 fluoride ions, so we put 2 as a subscript after the F. Now any chemist, anyone who looks at that, understands that the magnesium has to be a +2 and the fluoride has to be -1 for each of those. So this is the formula. For the name, we put the name of the cation and the name of the anion. So the name of this formula is magnesium fluoride. So remember that our anions end in IDE. Anions end in IDE. Cations, same name. Same as the neutral atom. That's kind of unfortunate, because if someone says sodium, you don't know if they're talking about the sodium ion or the neutral sodium atom. All right, so that's it. our electron transfer, our formula, and our name. Okay, let's do another one. Now we're going to do potassium and nitrogen. Potassium and nitrogen. Okay, so the first thing we're going to do is do the electron dot structure for each of our elements. So potassium is K. It's in group 1, so it is 1 valence electron. Nitrogen is in group 15, and it has 5 valence electrons. Potassium is a metal. Nitrogen is a non-metal. So now we're going to start our electron transfer. So potassium has its 1 valence electron. It's going to give it to nitrogen. So it's going to transfer it over here. And potassium loses its valence electron, so potassium becomes K plus. You lose one negative, you become one positive. So potassium's done. It emptied out its valence shell. Nitrogen wants to get 8. It needs the octet. So we need another electron to go right here. So we put in another potassium with its electron. So this potassium atom gives its electron to nitrogen, making that potassium a K plus. Now nitrogen has 1, 2, 3, 4, 5, 6, 7. It needs 8 to get the octet, so we're going to need another potassium. I'll put the electron there. That's going to give its electron to nitrogen. So we get another K plus. And now nitrogen has gained 3 electrons. That nitrogen becomes a 3 minus. So now we write our formula. So we have K for potassium and N for nitrogen. We have 1, 2, 3 potassium ions and 1 nitrogen ion. So K3N is our formula. And our name, K, the ion is the same as the neutral atom, so it's potassium. And nitrogen is negative, it's the anion, so it ends in IDE. It is nitride. Potassium nitride is the name of the compound formed from potassium and nitrogen. Okay, so next we're going to do calcium and oxygen. Okay, calcium is the metal to the left of the staircase. Oxygen is our non-metal. It is to the right of the staircase. So we're going to do our electron dot structures. Calcium Ca, and we put in 2 electrons. I'm going to put them there. And then we have oxygen that has 6. It's in group 16. So 1, 2, 3, 4, 5, 6. There's oxygen. So now we start transferring electrons from the metal to the non-metal. So we can put this electron here. And then calcium has another one to give, but oxygen needs another one. Remember, oxygen wants to get 8. It wants the octet. So we're going to move this one over there. Now we have Ca2+. Oxygen is gained 2 electrons, so it is O2-. So our formula, we have 1 calcium and 1 oxygen. So the formula is just CaO. And the name is calcium oxide. Anions end in IDE. Okay, we'll do one more. We will do aluminum and sulfur. Aluminum and sulfur. So aluminum is our metal. It is to the left of the staircase. Sulfur is our non-metal. It is to the right of the staircase. For ionic compounds, we always need a metal and a non-metal. All right, so let's start out with our electron dot structures. So aluminum has 3 valence electrons, and sulfur in group 16 has 6. And now we start the transfer. And we keep transferring until aluminum doesn't have any and sulfur has an octet. All right, so we can transfer this electron right here. Aluminum gets rid of it, and sulfur gains that electron. You have another spot open here, so this electron can go here. Cross that one out. Aluminum still has one valence electron that it needs to get rid of. Sulfur now is 1, 2, 3, 4, 5, 6, 7, 8. This sulfur is done. This is an S2 minus. It's full. It's done. So we have to get rid of this electron, so we're going to add another sulfur. So I'll put that over here, and we put in our 6. 1, 2, 3, 4, 5, 6. So now aluminum can get rid of its electron, give it to this sulfur. Aluminum is done. Now it is Al3+ because it lost all 3 of its valence electrons. We check this sulfur. 1, 2, 3, 4, 5, 6, 7. That's no good. Sulfur needs the octet. It needs 8 electrons in its valence shell. So that means we're going to have to add another aluminum, Al, with 3 valence electrons. 1, 2, 3. So now aluminum can give this electron to sulfur, and that electron is gone. Now this sulfur has 2, 4, 6, 8. This is S2 minus. It's got the octet. It's done. It's full. It's not going to take any more electrons. But our aluminum still has 2 valence electrons to get rid of. We can only give them to sulfur because we only have these 2 elements. So we're going to put in another sulfur and put in our 6 electrons. 1, 2, 3, 4, 5, 6. And transfer from the metal to the nonmetal. So this electron goes here. Cross that out. And then this electron can go here. So now our aluminum is done. It's an Al3+ ion now. Sulfur, 1, 2, 3, 4, 5, 6, 7, 8. It's done. We have an S2 minus. Everyone is good. Our metals have lost all their valence electrons. The non-metals have got the octet in their valence shell. Now we write our formula. So we have aluminum and sulfur. So we have 2 aluminum ions, so Al2. And we have 1, 2, 3 sulfur ions, S3, and our name, aluminum sulfide. You got to remember that our nonmetal ion ends in IDE. And that's it.